Okay, again, one of the properties of functions that comes up a lot in calculus is, or one of the ideas that comes up is whether you're dealing with an even or odd function, or and it's just another characteristic of a function that allows you to talk about some other things. So the textbook definition of an even function would be x squared, and the way we go about showing that something's algebraically even is we replace x with negative x, and we just kind of ask ourselves, did that do anything? And you'll kind of see what I'm talking about here. So if I square a negative, I get positive x squared. Okay, so the fact that this and this, that those two statements matched, tell me I'm dealing with an even function. Now, graphically, if you remember what the x squared function looks like, when we say it's symmetric about the y-axis, we are saying that the left and the right half both have the same image about them. Okay. Now, in comparison, we're going to go to talk about odd. Odd, f of x, textbook classic odd function that we see all the time would be x cubed. And so I'm going to replace x with negative x. And this time, if you square or cube a negative, if you cube a negative, you get a negative on the outside. And then notice that those two, the initial and the end result, are the exact opposites of each other. So when you're dealing with odd functions, you should see an expression that's the exact opposite of what you started off with. So let me kind of illustrate this graphically, what we're talking about here. So if I put in the cubic function, this piece in the first quadrant actually matches the piece in the third quadrant, but it's a reflection, what we call over the origin. So if you think about it, if you go down and left or up and right or something like that, you should get this sort of symmetry. Now, a lot of times in calculus, we don't actually ask you to draw it to identify symmetry. We ask you to do the algebraic definition of that. So that's what we're going to look at the bottom here and go through several examples of things that you could encounter. Okay, so in this first example, we have f of negative x equals, well, there's nowhere to evaluate the negative, so it still stays 2. And if I compare that to the original, it stayed the exact same, which tells me that that is an even function, that the left half and the right half must match each other. Okay. Number 2, if I replace x with negative x, so I get negative x cubed plus negative x. Well, the negative comes out, so it's negative x cubed, and this is minus x. And if I compare it to the initial, I notice that every single term is the exact opposite of the original ones, which tells me I'm dealing with an odd function of some kind. Okay, number 3, replace x with negative x. I get negative x squared minus a negative x. And this time I get a negative x squared would be positive x squared plus x. Now, something interesting. I compare that to the original. The first terms are the same, but the second terms are opposite. So I've kind of got this hybrid scenario going on here. This is actually an example of neither. It's not even or odd. Doesn't fit either definition exactly, so it's neither. Okay. Next set, number 4. Alright, so we got 2 absolute value of negative x minus negative x squared. Alright, well, 2 times the absolute value of negative x, that's just 2 x. And then the minus, because you square the negative x, you still get x squared out of that. Now, just think about definition here. If you compare that to the original, yeah, the symbols sort of disappeared on us, but the signs of the two absolute value x, that's a positive term, this is a positive term. The minus x squared is minus, it's minus. So it actually stays the exact same. And so this would be an example of an even function. And number 5, evaluate that at negative x. We get negative x plus 1. This doesn't quite fit either. It doesn't, it's in a sided square root. So this would be something where we'd say is neither. Okay, so with this next one, when we replace x with negative x, okay, so we get negative x in the numerator and negative x squared minus 1 in the denominator. Okay, now let's talk about the denominator for just a second. With x squared minus 1, we're always going to get a positive number in that denominator. However, the numerator is the exact opposite of the original numerator. Okay, so we have a fraction that the value of which has the same number except the sign is the exact opposite. So this is a situation where the original function and essentially f of negative x is the exact opposite of f of x. Okay, so this would be something that we would call an odd function. Okay, number 7, do f of negative x goes 1 over negative x squared minus 1. Okay, so this is a simplified form of number 6. So we're going to get 1 over x squared minus 1. And that's the exact same as our initial function. So this would be an even function. Okay, number 8, f of negative x. This time we only change the numerator to be a negative. We did change the denominator a little bit to be x squared plus 1. So when we put a negative in, though, we get the numerator stays the same. The denominator also stays the same. So this is another illustration of even. All right, and then this last case, f of negative x. So we get negative x cubed over negative x squared minus 1. Okay, the numerator still stays positive. The denominator, however, it's kind of like number 6. It's become the exact opposite of the original. So this would be an illustration of an odd function.